All right, so we'll go over notes real quick for percent yield. If you look on the blog or the Unit 3 tab, I'm using the, let's see, percent yield homework sheet. So that's the name of it. I'm using that to go over the notes. I'll use number 1 to explain to you percent yield. And so when we look at percent yield, so the first thing is we have a formula. And so we should know that a percent is equal to a part over a whole. We've talked about that before. And so when we look in chemistry, when we look at percent yield, we're just looking at, so how much did you make? So in your chemical reaction, how much product did you make? And we're gonna compare that to how much you should have made. And so when we look at our formula, we're looking at our actual yield divided by our theoretical yield, and to turn it into a percent, we're gonna multiply it by 100. And so here we're gonna look at actual versus theoretical. You already know, you kind of know how to get these numbers. We haven't specifically called them the yields yet, but it's gonna be pretty easy once you have this formula to find the percent yield. And so the actual yield, this is what you actually get if you were to do a lab. And so if we were in school, we would actually do a lab probably tomorrow, and we would actually measure with our balances. We'd measure the actual yield, but we can't do that. So for us, we're either gonna get the actual yield, it's what you actually get in lab, or for us, you're gonna have to be given the actual yield within the problem. So this would be like on a test or quiz or on these worksheets. If we're asking you to find the percent yield, the actual yield is what you actually get. It'll be given to you. And then so that leaves a theoretical yield. The theoretical yield is what you should get in theory. If you were perfect, if you did everything the right way, this is what we would theoretically get. And we calculate this. How do we calculate it? We calculate it using a BCA table. And so if you think back to last week, the last couple days of problems when you were solving for the mass or the grams of a product, all you were finding was the theoretical yield. And so if we know how to find this through making a BCA table, you can find that value in grams. You know your actual yield that's given to you in the problems. If you just divide those two numbers and multiply by 100, we can get to our percent yield. So you're looking at number 1 from the worksheet. I began this reaction with 20 grams of lithium hydroxide. What is my theoretical yield of lithium chloride? So this breaks it up into A and B. And so we'll look at, they give us the balanced chemical reaction. And you may be looking at this, how do I know I need a BCA table? Well, first thing is they gave us 20 grams of lithium hydroxide, and they're asking us to convert to lithium chloride. So we gotta convert from lithium hydroxide to lithium chloride, substance A to substance B. So one substance to a completely different substance. That should tell you a BCA table. And so when we're finding theoretical yield, you see the question, what is my theoretical yield? The only way to find theoretical yield is through a BCA table. And so as we're filling our table in, we know I have 0 of this to start with, my products. We're filling in minus x and minus x, plus x, plus x. It's already balanced, so we didn't have to balance it. We've got to convert grams of lithium hydroxide. So grams of lithium hydroxide in 1 mole. We can find the molar mass of lithium hydroxide. .91, and so we can get to 0.836 moles. And so that's lithium hydroxide. Now when we look back at the question says nothing about KCl or potassium chloride, so we don't really need to worry about that. And the question says, what's the theoretical yield of lithium chloride? Well, lithium chloride is here, so we don't care about this either. And so here, we know that this will be the one that goes to 0. 0.836 minus x equals 0. We know that x equals 0.836. We can then plug our x value in right here. And then we can get that this is 0.836 moles. Now, we'll come down here, 0.836 moles of LiCl. Just like we were doing last week, we can convert 1 mole of LiCl, we can find the mass. And we're gonna get 35.44 grams of LiCl. Now, I'll underline this and let you know that this is our theoretical yield, right? This is what you found last week. So again, that worksheet, we're ending on finding the grams of a product. That's just the theoretical yield. So we found that. And so then this would be the answer to part A. But then part B, what's the percent yield? Well, we know percent yield is actual over theoretical times 100, right? And so we know that the actual is in the problem. I actually produced 6 grams. So actual is 6 grams divided by my theoretical, which is 35.44 grams. We multiply that by 100. And we're getting 16.93%, and that's our percent yield. And so is that good or bad? Well, you can think of percent yield as your test grade. Would you want to get a 17%, 16.93% on your test? No. And so what does that mean? When we look at percent yield, that means you only got 16.93% of what you should have gotten. So if you're working for a company and you get that, you're probably going to get fired. So understand that the percent yield closest to 100 would be the best case scenario. So again, you've got to have actual over theoretical. Actual is going to be given to you in the problem, and then theoretical is what we can solve for. So again, theoretical yield is what we calculate through a BCA table. It's what we were working on last week. So to do percent yield, we're just taking the theoretical yield we were calculating last week, and now we're applying it to this percent yield formula. You wouldn't be given this formula in a test or quiz, so I would make sure that you memorize this formula right here.